Question 11A of the WAS 2018 Mathematics Theory question, that's your WAEC theory question. It says, copy and complete the table of values for y, this should be an equal to sign here, equal to 2x squared plus x minus 10 for these values. That is what x is what greater than or equal to minus 5 and x is less than or equal to what 4. So we're to complete this table, okay? So we're going to solve this out. So we're going to put in the values of x into this equation to get at different values of y from x as minus 5 to what 4. Okay, we have to solve this out. It carries a mark. Okay, and we'll definitely go to our graph, and I'm going to explain in detail how to draw a graph. Okay, because this is when so many students ask questions on, oh, please do a graph for us. So this is very key. I'm going to explain some things on graph, then we'll plot our graph together. Okay, it might not be perfect, but I'm going to show you the steps. All right, okay, so let us complete our table first. Now, so we have this. Okay, let's draw a line. So this is the equation y is equal to what? 2x squared plus x minus what? 10. So from here, if your x squared is taking a positive sign, there's no negative here, it means the graph of this, the shape of the graph of this graph is going to be a U. But when you have this x squared taking a negative, you are going to have what? An n. Okay, the shape of your graph will be here. So when you have the equation, you should at least know the shape of how the shape of your graph is, so that when you start drawing and your shape is going like n, then you should know you have made a mistake somewhere. So when x squared is taking a positive sign, the shape of your graph will be a U. But when x squared from your question is a negative, the shape of your graph will be what? An n. Okay, note that, it's very key. Okay, so you know when you're drawing your graph, when you're going in another direction, you should know you've made a mistake from your completing the table. Okay, all right, so when x, let us start solving this. So when x is equal to minus 5, so let's put in the values of x as minus 5 into this equation. Now you have to be very careful here, okay, so you don't miss your signs. All right, so you have here y is equal to what? 2 bracket what? Minus 5 square plus bracket minus 5, then minus what? 10. So from here, what do you have? This is what? 2 times what? 25. Is that not it? Minus 5 square, the minus will cancel out, so we have 25 times what? 25. Here, this plus multiplied by this negative here will be a negative 5, negative what? 10. So you are left here with 2 times 25 is what? 50, and minus 5 minus 10 is what? Minus what? 15. So it's equal to what? 35. So our first value here is 35, so we write 35 here. Okay, so what's the next value is what? X is equal to what? Minus 4. Okay, so we put in our value of minus 4, so we have 2 bracket minus 4 square plus bracket minus 4, then minus what? 10. So what do we have here? We have 2 times 4 square, that's minus 4 square, will give us what? 16. Then plus times this minus here will give us a negative 4, negative what? 10. And what is 2 times 16? 2 times 16 will give us what? 32. And we have minus 4 minus 10 will give us what? Minus what? 14. And 32 minus 14 will give us what? 18. Okay, so this is what? 18. So we've been given this value here, and we have to look for what? This minus 2. Okay, so for x equal to minus 2, so we have y is equal to 2 bracket minus 2 square plus bracket minus 2 bracket close bracket minus what? 10. So here what do we have? We have 2 times what? 4. Is that not it? Minus 2 square is what? 4 plus, no, not plus, you see where plus times negative will give us what? A negative. So negative 2 minus what? 10. So here what are we left with? We are left with what? 2 times 4 is what? 8. And minus 2 minus 10 will give us what? Minus what? 12. And what is my 8 minus 12? That will give us a negative what? 4. Is that not it? So we have a negative 4 here. So for minus 2 we have what? A negative 4. The next value we have to look for is when x is what? 1. Okay, so when x is equal to what? 1, what do we have? Our y will be equal to what? 2 bracket 1 square, okay, plus bracket 1, then 1, then minus what? 10. So what do we have here? 1 square is still 1, so we have 2 plus 1 minus what 10. Is that not it? That is what 2 plus 1, and 2 plus 1 is what 3 minus 10. And what's 3 minus 10? That will give us what minus 7. So this would be what minus 7. So here we have 3. So when x is equal to 3, what do we have? Y is equal to what? 2 bracket 3 square plus 3 or bracket minus what 10. So what is 3 squared? That is 9. So we have 2 times 9 plus 3, then minus what 10. What's 2 times 9? We have what 18. Is that not it? 18 plus 3 will give us 21. Then 21 minus 10. What would that give us? What would that give us? That will give us what? 11. Okay, that's 21 minus 10 will give us what? 11. Okay, so the value of when x is 3, our y is what? 11. So our final one what to look for is what? X is equal to what? 4. Okay, so we have y is equal to 2 bracket 4 square plus or bracket 4, then minus what 10. Okay, so here we have 4 square, that's 16. So 2 times what 16 plus 4 minus 10. Okay, what's 2 times 16? That will give us what 32 plus 4 minus 10. And what's 32 plus 4? That will give us what 36. And what's 36 minus 10? That will give us what 26. So we have what here 26. Okay, so this is our table. We've completed the table. Okay, so all you need to do on your book, draw out this table, then state this value. So this is the answer to question 11A. You must do your workings too. Okay, that's why I did it. We did it together. Be careful with your signs. This is where students miss points. Okay, because when you miss your sign here, like I think I made a mistake here. If you miss it, you're going to get a value, and which is going to change your curve. All right, that's the curve of the equation. So be careful, slow down here a bit, okay, and be very accurate, and go back to check if you missed anything. All right, so we have our table here. Now it's for us to plot our graph. So question 11B says we should plot the graph of this. Remember from 11A, that's y equal to 2x squared plus x minus 10. Okay, using the scale 2 centimeter to 1 unit, that's on the x-axis, and the scale 2 centimeter to 5 units on the y-axis. Okay, so you can see I'm using the standard. Okay, if you look at this particular notebook, this is a YX standard graph sheet. Okay, I hope that's what you use everywhere in Africa. Okay, but we are going to be using this graph sheet. So why I'm doing this like a real physical video, not a digital video where I put in a digital copy of this, then plot on a whiteboard. Okay, is for you to connect, okay, with me directly. This is like a real life situation. So we're going to draw this graph together. So I'm going to be telling you some tips on plotting a graph. Okay, now the first tip is I need you to understand your scale. Okay, and in WAEC they would give you a scale. Please make sure you don't go and use your own scale, because that's where you start failing it. Make sure you use the scale given in the question. And this question says 2 centimeter to 1 unit on the x-axis. Now, what do they mean by 2 centimeter? I know that's the first thing you might want to know. What's 2 centimeter? Because some questions might tell you use 1 centimeter to 1 unit, or 1 centimeter to 2 units. So what does this unit mean? What does this centimeter mean? Okay, let me explain it to you properly before we go forward with our own question. Now, the centimeter here, for instance, they say 2 centimeter. 2 centimeter on your graph sheet is from here to here. All right, and 1 centimeter is from here. You're going to count 5. 1, 2, 3, 4, 5. So here, this is 1 centimeter. Okay, while from here to here is 2 centimeter. And if you count the lines in the 2 centimeter, they are going to be equal to 10. Let's count together. We have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you see you have 10 boxes. 10 little of this cube would make up 2 centimeter, while 5 of these boxes, these lines, okay, that's horizontal lines, okay, would make up 1 centimeter. So for instance, you are told to use 1 centimeter to 1 unit. Okay, let me explain this unit now. This unit means like a number. So FU is like saying every centimeter, give it a particular number. Are you following me? Now, for instance, if we have here, if the question says 1 centimeter to 1 unit, it means every 1 centimeter will be equal to what? 1. The next centimeter, you are going to add 1, which will be what? 2. The next centimeter will be what? 3. That's every 1 centimeter, all right? Okay, so but for our question here, let's erase this, okay? Always make sure you have a good eraser, and also you have to have a HB pencil. Sorry, I'm not using a HB pencil here, okay? But for you, please make sure you get a HB pencil, all right? Okay, and a very good eraser. So here, our question now says what? The first thing on the x-axis, and remember, where is your y and x-axis, okay? Your y-axis is this way, and your x-axis is what? This way. Your x-axis is always what? Horizontal, while your y-axis is what? Vertical, all right? Make sure you know that your y and your x-axis. Okay, so it says on the x-axis 2 centimeter to 1 unit. So it means that from here to here, which is 2 centimeter, we are going to have what? 1 unit. All right, and it also says on the y-axis 2 centimeter to 5 units. So on the sorry, this is supposed to be from here to here. Okay, for the y-axis it says 2 centimeter to what? 5. So the 5 is just like a number. It could be 2 centimeter to 3 units. It could be 2 centimeter to 7 units. It could be 2 centimeter to what? 10 units. Okay, or 1 centimeter to 2 units. 1 centimeter to what? 5 units. But let me state, if this is if for instance it is 1 centimeter to 10 units, so it means on the x-axis, so it means that from here to here will be what? 10. Then you add another 10 from here to here, which is 1 centimeter. Another 1 centimeter will be what? 20. Add another 10. Then another 1 centimeter. You add a 10 to this 20. We are going to have what? 30. Okay. Or if it says 1 centimeter to 5 units, let's say on the y-axis, I mean. So it means that from here to here, which is 1 centimeter, here will be what? 5. What? 5. Okay. And from here to here, you add another 5. It will be what? 10. So I hope we understand now the meaning of the centimeter to units. Okay, so now let's plot our graph. Okay, and we're going to look at this again. All right, so we have to plot our graph now. Okay, you have to have a ruler. Now let's draw a line for our y-axis. Okay. Apologize once more that this isn't a HB pencil because it's supposed to be thicker. Okay, so you could see it clearly. All right. Okay, so now let's draw this for our y-axis, right? All right, and you can see here the highest value of our y-axis is what? 35. Is that not it? 35. Okay, so it means that, and this is a positive 35. All right, so and our positive is up here, while our negative is what? Down here. All right, and the highest value for our negative axis on the y-axis is also 9. So it means, you know, let's put our graph in such a way that, you know, since 35 is more, so let's draw the x-axis a little bit downward here. Okay, I think we can keep it somewhere here. All right, the y-axis says 2 centimeter to 5 units. Okay, so 2 centimeter to 5 units, that would be a 5, 10, 15, 20, 25, 30, 35. Okay, what should we do? Okay, I think we can still bring it down, since here this is just -9, so we can have, like, if we put it here, if we put our x-axis here, we'll have like a 5 and 10. Is that not it? Okay, and we have a -10 here, so we can have a 5 and 10. We can actually bring it a bit down. All right. Okay, why I'm actually doing this, before you start drawing, you have to actually try to, you know, just scale out your graph. All right, since here you have 35, which is the highest positive value, so it means that the positive portion of the y-axis have to be what? More. okay, and the negative portion, the highest negative value here is -10, so we can easily put minus the values here, the units here of -10 can easily be, we can easily get it down here. All right, that's why I'm doing this, okay. And before we even plot our y, we're even supposed to check our x out, because we have -5. -5 will be all this way, and a positive 4 would be this way. So I think it's even best we would have put a y axis here, this on this line, but it's still okay. So let's draw our x axis. Okay, I'm trying to make this thing dark so you see it, okay. All right, but if you're using a HB pencil, just drawing it once it would be dark and clear enough, okay. All right, okay, so this is our y-axis. State it, and this is our x-axis, okay. State it. All right, okay, so from here this is 0, so let us put in our values. Now it says what our scale. Let's do our scale down. Our scale on the x-axis says what 2 centimeters to what 1 unit, okay. So 2 centimeters to 1 unit, that will be here will be 1, here will be 2, that is 2 centimeters to 1 unit. Then here will be what 3, here will be what 4, and here will be 5, okay. So on this side this is negative, so here will be what minus what 1, and here will be what a negative what 2, here will be what a negative what 3, and here will be what a negative what 4, and here will be a negative 5, okay. So it says on our y-axis we have 2 centimeters to 5 units, okay. So 2 centimeters to 5 units, 2 centimeters to 5 units on our y-axis. So it means from here to here will be what 5 centimeters, okay. That's 2 centimeters to 5. So from here to here will be what 5, okay. To here will be what 10, here will be what 15. So every 2 centimeters add a 5. That's what it means. Here will be what 20, here will be what 25, here will be 30, and here will be what 35. We can leave it at 35, or we can just add one more, and here will be what 40, okay. But we know we're going to stop at what 35, okay. So now on the negative part of what our y-axis, here will be what a 5, -5, okay, and here will be what a negative what 10, okay. I hope you can see that. So here is a -5, and here is a negative what 10. Or should I use a pen so you could see, we could see together? Okay, let's use, I think we should use a pen, all right, instead of using a pencil, so you could see the values, all right, because I know it might not be so clear, but let's use a pen, okay. All right, so this is a 5 here, a -5, a -10. So this is 1 here, this is 2, this is 3, this is 4, and this is 5. This is a -1, a -2, a -3, a -4, and a -5, okay. This is a 5 here, this is a 10 here, this is 15, this is 20, this is 25, this is 30, this is 35, and this is what 40. Okay, so now let's plot our graph, and this is what 0. So let's plot our graph. It now says when x is what -5, y is what 35. So it means x is -5, y is what 35. So this is our first point here. So you make a star here, okay. The next point, when x is -4, y is what? 18. Okay, minus 4. Where would 18 fall? Okay, so now this is 15. So it means this will be 16. This is 17. 18, 19, 20. Now, this is where the trick, there's another, you have to understand this now. So it means here from 15 to 20, what are the values between it? So from here to here will be what? If this is 15, from here to here is 16. So 2 lines will give us what? 16. This from here to here will be what? 17. From here to here will be 18. From here to here will be 19. And from here to here will be what? About 20. So in explain how you can know the value of each of these lines here. Well, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's each of this line between 5 and 10, or 0 and 5, or 10 and 15. Now to know this, since we know that the y-axis says 2 centimeter to 5 units, okay, and two in a 2 centimeter box, okay, which is from here to here, as I said earlier, in a 2 centimeter box you have what? 10 what lines, okay? That's you have 10 of these small boxes, these small square boxes. That's you have 10 horizontal what? Lines. If we count it, we have here, from here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's for a 2 centimeter box. But for a 1 centimeter we have 5. And remember I said 1 centimeter is from here, 1, you have here 1, 2, 3, 4, 5. Okay, so for a 2 centimeter box you have what? 10 what of these boxes, that's the lines. All right, and here we're told 2 centimeter to 5 units. So simply to get each of the value of these lines, these boxes, we just say what? 5 divided by what? 10. Okay, since it's 2 centimeter to 5 units, and each 2 centimeter we have 10 boxes, so we say 5 divided by 10. And what is 5 divided by 10? That will give us what? 0.5. Okay, and so definitely each of this line will be what? 0.5. So you have from here to here is 0.5. You add another 0.5 here, we have 1. Another 0.5 times plus 1, we have 1.5. 1.5 plus 0.5, we have 2. So it means here is 1, here is 2. That's each 2 boxes. We have 1, 2, we have 3, we have 4, then 5. Okay? All right, so but from here, from 5 to 10, what do we have here? If this is 5, this here will be 6, here will be 7, here will be 8, here will be 9, and definitely here is what? 10. And if this is 10, it means here will be what? 11. You know, from here to here is 10.5. 10.5 plus another 0.5 will give us 11. Okay, so I'm just making it easier that each 2 boxes will be 1. Okay, so here would be what? 12, here will be 13, here will be 14, and here will be what? 15. Now on the x-axis, now how do we get to know each of these little boxes? What is the value for each of these boxes here? That's each of the lines. Okay, you know, in 2 centimeter, okay, we have 10 what? Lines. Okay, that's 10 of these boxes. Now from here, our x-axis says what? 2 centimeter to what? 1 unit. So all we need to do is just say what? 1 divided by 10. And what is 1 divided by 10? That will give us what? 0.1. So it means now that each of this line is what? 0.1. Okay, so you have 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, then 0.9 plus another 0.1 will give us what? A 1. So it means from here we have 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9, then a 2. So I hope you now understand how you can get the values of each of these points. So if you're just giving your 2 centimeter to 1 unit, all you need to do is just divide 1 over what? 10. If it was 1 centimeter to, let's say, 2 units, remember you have 5. You have 5 of the blocks, okay, in a 1 centimeter. So all you need to do is divide what? 2 divided by what? 5, okay, and that will give you the value of each of the lines. All right, okay, and 2 divided by 5 is definitely what? 0.4. Okay, so that's how you get the value of each of these lines. Okay, that's in case you are confused about it. You know, it can get a student confused. Even me, right, when I was also learning on graph, this also got me confused. So that's how you can what? get it. Okay, that's why from here to here is 16, from here to here is 17, this is 18, this is 19, and this is what, 20. Okay, and our value says, our table says minus 4 is equal to what, 18. So we have here minus 4, and let's trace 18. So here will be what, from here to here is 16, 17, and 18. So 18 is what's here. So this is our point for 18. Okay, so this is 18. All right, now the next value says minus 3. X is minus 3 when y is what, 5. Okay, so y is what, 5, and x is what, minus 3. So this is the point here. Okay, now the next thing says what, when x is minus 2, y is what, minus 4. Okay, so when x is minus 2, y is what, minus 4. Okay, y is minus 4. So we're still going to apply the same principle since we still have what, 2 centimeters to 5 units. Okay, so if this is minus 5, from here to here will be what, minus 4. That's, here will be minus 4, here will be minus 3, here will be minus what, 2, here will be minus 1, and here will definitely be what, 0. So we have minus 2 and what, minus 4. So minus 4 will be what, here. This is a point for minus 4. Okay, minus 2, and y minus what, 4. Now the next value says what, when x is what, minus 1, y is what, minus what, 9. Okay, so this is minus 1, y will be what, minus what, 9. So minus 9 is what, here. Okay, so if this is minus 10, the next 2 points will be what, up will be what, minus what, 9. So x is what, minus 1, and y is what, minus 9. So we have it here. Our point is what, here. Okay, now the next thing it says when x is 0, y is what, minus 10. Okay, so x is 0, x at 0, y is what, minus 10, and this is what, minus 10. Okay, so this is our point here. All right, the next value says when x is 1, y is what, minus what, 7. So where is minus 7? This is x is 1. Where is minus 7? Okay, so if this is minus 10, it means here is minus 9, this is minus 8, and here is what, minus what, 7. So trace it down here, since we have here as what, x is what, 1, and y is what, minus 7. So this is our point here. Okay, are you following me? If you have any questions, just feel free to drop a comment in this video. Okay, all right, so the next value says when x is what, 2, y is what, 0. Okay, so when x is 2, y is 0. So at y 0, x is what, 2. So this is our point here. All right, okay, the next value says when x is 3, y is what, 11. Okay, x is 3, y is 11. If this is 10, definitely the next 2 points will be what, 11. So this is 11. When x is 3, y is 11. Okay, that's y is 11. The next point says when x is 4, y is what, 26. Okay, 26 when x is 4. Okay, if this is 25, then it means the next 2 boxes is what, 26. So y is what, 26 when x is what, 4. Okay, so this is our point. All right, have you gotten it? So this is the way our graph would what be. So now it's for us to now trace this point. Okay, trace this point out. Okay, in tracing your point out now on the graph, you have several methods. I remember them back then in school. I used broomstick. Okay, I'm still quite old school, but I think right now you can use a French curve. I don't know how to use a French curve, so I'm going to use the broomstick here. Okay, but I think French curve could be more easier, but I have a broomstick here, so that's what we're going to use. Okay, and I'm going to use my pen so we see the lines. Okay, so this is my broomstick. You can take your broomstick if you want to the exam hall. I don't think the examiner would disturb you with it, but okay. All right, so I have this, so we can draw the first line. We're just going to trace it, okay, together. All right, I'm going to use my pen. Okay, and sorry, I didn't know when my phone stopped recording. I think a call came in, so I actually drew this part of the graph. Okay, you didn't see that, but we're going to draw this together, okay, and you're going to see it, okay? So let's get these points together. So how do we do this? Still using my broomstick, okay? I'm using a pen here. Okay, gotten those 2 points. All right, so let me try to get this point now. I hope you can see this clearly. Okay. Yeah, I can do it this way. Okay. A little bit bent here. All right. Okay. Just one step here. Okay, I think I've gotten it now. All right. Okay. Yeah, great. Gotten that point now. All right. Okay. So let's try to get this point. We're almost done. Okay, just look for a very straight part of the broomstick, all right? Just curve this. I think a French curve would be better, right? But I'm still old-fashioned. Don't mind me, please. But the basic key things of a curve is your points, getting your points right, then trying to get the curve. All right, I think, yep, good, good. Okay, let's get these 2 points now. We're almost done. Okay. Are you with me? Stay with me, okay? So you can see when you're picking your questions, you know, part B, this graph is part of part B in your theory question. So you should know that this will take some time. So time yourself. Your theory takes 2 hours 30 minutes. The first part is compulsory, so try to be fast with the first part because the third part is quite hard. I think you select in the third part there are 8 questions. I think you get to select, I don't know if it's 3 or 4 right now. Okay, we've gotten this. Yeah, just the last one remaining now. Okay, just 1 minute. Let's do this together. Okay. Oh, great. 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 Okay, so you can see our curve. I think I tried a bit, right? Okay. Okay, when you're using your pencil, it's going to be quite easy for you because you know you can erase, then use your pen, the broom to also make it better. But I think this is fairly good. All right. Okay, so this is the curve. All right. This is the first part of the question, which says draw the graph. Okay, plot the graph using our scales which we've used. Then on your graph, also make sure on this graph, just write here y is equal to, for the examiner, it's actually another additional point. You say y, this is the graph of y is equal to what, 2x squared plus what, x minus 10. That's on the graph. Write it on this line. All right, so it says that this is the graph of this equation. All right, okay, so we have this. Now what's the next thing for us to do? Question B, that's for the same 11b, okay, which is this. Now in 11c, we have 11abc. 11c says use the graph to find the solution of, it says we should find the solution of I 2x squared plus x minus 10. Okay, no, not minus, equal to 10, and I 2x squared plus x minus 10 equal to 2x. Okay, so we have to find that. That's what the question, the second part, that's 11C. All right, so to find 11CI, that is 11CI, we have here 11CI, 2x squared plus x equal to what? 10. It says we should find what? We should find the solution of this using what? Our graph. So from here, we have to equate this to look as this, y equal to what? 2x squared plus what? X minus 10. Okay, that's, we have to make this equation look as in equate it to look as like this. Okay, in doing that, we are going to have here 2x squared plus x, taking 10 to this side, we have minus 10 equal to, we are going to be left with what? A 0. So it means here that y is equal to what? 0. Okay, so y equal to 0. So from here, to get the solution of this, it means we are going to have two values of what? X. Okay, and at y equal to 0. So where is y equal to 0? Y is equal to 0 here. So on the graph, okay, we're going to check at the point where y is equal to 0, where did the graph touch what? The x-axis. Okay, and that is what we know as what? The roots of the equation. Okay, that is what we know as what? The roots of the equation, where the points where the curve touches what? The x what? Axis at y equal to 0. So where does the point of the curve touch the x-axis? We are going to trace that down. So here we have one point here. One point is what? X. So here x is equal to 2, or this next point, what point is this? See this point here? We have a point here, and this is like this is 2 here, and this is like the middle. This is the mid. It cuts it. Can you see this? I hope we can see this. Okay, so it cut at this point here, and at this point, this is the mid between 3 and 2, and which is what? 2.5. Okay, so we have 2.5 here. This is like saying 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7, 2.8, 2.9, and 3. So it cuts here at what? 2.5. So x is equal to 2, or x is equal to what? 2.5. So this is the solution of what? This equation. X is equal to 2, or x equal to what? 2.5. Now we have the next question. Says find the solution of what? This. So we have 11CII, which says 2x squared plus what? X minus 10 equal to what? 2x. So here it means that y is equal to what? 2x. Okay, so this means this would make us to what? Form a table. All right, we have to form a table, then look for the line of y equal to what? 2x. And in forming the table, we're going to still use the values of x from x as minus 5 to what? 4. Okay, so let's do this together. So we have here, let's just plot the table first. We have x, okay, minus 5, minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, then 4. Y. Okay, so what will be y when x is what? Minus 5. Let's solve this together. Let's use the space here. Let's just manage the space. I hope you can see this. Okay, all right, I'm just checking the camera to see if you can see it. Okay, I hope you can see it together. Okay, all right, so so when y, so what will be y when x is what? Minus 5. So we have here 2 times what? Minus 5. And what will be 2 times minus 5? We have a minus 10. So we have a minus 10 here. When x is what? Minus 4, what do we have? Times minus 4, we have what? A minus what? 8. So this will be a minus 8. When x 2 times what? Minus 3, we're going to have a minus 6. So this will be a minus 6. So we have y 2 times what? When x is minus 2 minus 2, we have a minus 4. When this will be now, okay, let's put it here. Sorry, this shouldn't be minus 4, this should be minus 6. Okay, 2 times minus 2, we have what? A minus 4. And here we have what? 2 times minus 1, we're going to have a minus 2. So we put a minus 2 here. And here we have what? 2 times what? 0, we have 0. Okay, we'll put a 0 here. We have y equals to 2 times 1. We have a 2 here. Y is equal to 2 times 2. We are going to have a 4. That's why we have a 4 here. Y equal to 2 times 3. We're going to have a 6. This will be a 6. And finally, y equal to 2 times 4. We're going to have what? 8. So this will be 8. So this is our table. This is our table for what? When y is equal to what? 2x. So we're going to plot this graph here. Then where this this equation, the equation of the line touches your curve, we are going to trace those 2 points, and that will be the solution of this what? This final, the last what equation. Okay, so let's plot the graph. When x is what? Minus 5. When x is minus 5, y is what? Minus. When x is minus 5, y is minus 10. Okay, so we're going to have something here. When x is minus 5, y is minus 10. When x is minus 4, y is minus what? 8. What will be 8? This will be 9. So we're going to have 8 somewhere here. Okay, and when x is minus 3, y is minus 6. 6 will be somewhere here. Okay, when x is minus 3, sorry, when x is minus 2, y is minus 4. Okay, so it's going to cut here. All right, so this is minus 4. And here, when x is minus 1, y is what? Minus 2. Y is minus 2. This is 4. This is 4. This is 3. And this will be 2. So we are going to have the point here. All right, here. Okay, that's for minus 1. And when x is 0, y is also 0. So we have a point that's going to cross here, the mid. Okay, and here we have here when x is 1, when x is 1, y is what? 2. So if this is 1, x is 1, we on the y-axis this is 1 and 2. So we're going to have it here. X is 1 and y is what? 2. And when x is 2, y is 4. So if this is 2, okay, this will be 3 and this will be 4. So y is what? 4 here. The next one, when x is 3, when x is 3, y is what? This is 6. Okay, when x is 3, y is 6. So where this is 3. Okay, where is 6? If this is 5, if this is 5, this will be what? 6. Is that not it? Okay, and when x is 4, y is 10. Y is when x is 4, y is what? 8. Let us look for 8. This is x at 4. Okay, this is 5, 6, 7, and 8. So this is 8. When x is 4, y is what? 8. Okay, so here we're going to draw a straight line. And try to get all the points. Okay. All right. I think this should do this. Do it. Okay. Now I'm using a pen. So it's going to be very different when you're using a pencil. Okay? Okay. All right, so this is the line here. And you write on the line, y is equal to what? 2x. So the point at which the line crosses the curve, we're going to trace it down to x. Okay? So let's assume it's here, that it touches. Let's just pick this point here. Okay? So it picks it here. So we trace it down to x. And this one we trace down to what? X. Okay, so here what do we have? Tracing the point at which this line cuts the curve, tracing it down here, we have what? A 2.5. This is 2.5. This is 2. This is 2.1, 2.2, 2.3, 2.4, and 2.5. So one of the solution to this equation is what? X is equal to what? 2.5. And the next solution is it touches the line touches the curve here, and when we trace up, we get what? A -2, or x equal to what? -2. Okay, so this is the solution of 11C. Okay, so this is everything about plotting the graph. I hope you understand this properly, and I hope I was able to connect with you also, which is the purpose of why I said I should do this physically, so you understand it. So I hope you really get this. Okay, so this is simply how you draw a graph. You don't use a pen, please don't use a pen, use a HP pencil. Okay, and if you would love to use a French call, fine, but I'm used to the broomstick. That's how I learned mine about 16 years ago while writing my WAEC. Okay, so you can use it. You can see my own graph here. I think it's quite okay. All right, so this is the way you find the solution of, after, in the graphs, after you plot the graph, they always try to make you look for, it's either they stated find the solution of these equations, or they ask you find the roots of this equation. It is still the same. Don't be confused. When they say root of the equation, it's still the same as finding the solution of the equation. Okay, so finding the solution of the equation, it means the root of the equation. So when you're given the equation, formulate it, let it look like this, and if it gives us that y, as we said here, when we brought 10 to this side, it became a minus. You can see it's the same as this, so we equate it towards 0. Are you getting it? Since y is equal to 0, so definitely the points will be where the curve crosses the x-axis at y equal to 0. So the point at y equal to 0, we trace them down, and where we got this point and this point. This is our solution. Oh, sorry, this should be a negative. Okay, this is a negative 2.5. okay, because we took it from a negative 2.5. all right, sorry, this is a negative 2.5, not a positive. All right, okay, so that is how you find the solution of the equation. And you can see how we did this for here. We still had to form a table and plot the straight line graph, and where it touched the curve, that's where we have our point, which is the solution to the equation. That's the root of the equation. All right, so thank you. So let's get on to the next question. Question 12A of the WAS 2018 mathematics theory question. It says if x is this, that's 2 and 3, and y is 5 and -2, and z is -4 and 13. Find scalars p and q such that px plus pq is equal to z. Okay, let's try to find this. So we have here pq plus qy is equal to z. So from here we have here p. What is x? X is 2 and 3 plus q. And what is y? Y is 5 and -2. And what is z here? Z is equal to -4 and 13. So we're going to just treat it the way we're going to multiply out like the way we do in matrix. Okay, so here we have p times this will give us 2p, and p times this will give us 3p, plus q times this will give us 5q, and q times this, that's a positive and a negative, definitely to be a negative, plus times minus will give us a minus, so we have minus 2q. So we have equal to, this will be first equal to -4, then this will be equal to 13. Okay, so here we have two equations. Okay, and when you have two equations, equation 1 and equation 2, this is simultaneous equation. So you can either use elimination method or substitution method to solve this two equation, which is a simultaneous equation. So from here I'm going to use elimination method, and in using elimination method I'll try to cancel out p, and to cancel out p I will this p on this two equation, I will multiply equation 1 by 3 and multiply equation 2 by 2. Okay, so in multiplying, what are we going to get? We're going to get here 3 times 2p, we're going to get 6p, plus 3 times 5q, we're going to get 15q, equal to 3 times -4, we are going to get -12, and 2 times 3p here, we're going to get 6p, and 2 times -2 here, we're going to get -4q, equal to 2 times 13, we're going to get 26. Okay, so from here we have equation 3 and equation 4. All right, so we can easily cancel out p. Now to cancel out p, since these are positive, we have to introduce a negative sign so that this becomes 0. Okay, and when we introduce a negative sign, we'll multiply equation 4 by a negative sign. Okay, That's everything here by negative. So this will be negative. This negative here will become a positive, and 26 will carry a negative sign. Okay, so let's do this here. All right, so this will cancel out. So we have plus 15 plus 4, that will give us what? 19 what? Q. And minus 12 minus 26 will give us what? Is equal to a minus what? 38. So here we have here 19Q equal to what? Minus what? 38. So divide both sides by 19. 19 will cancel. We're left with what? 19 in 38 will go 2 times. So we're left with what? Q is equal to what? Minus 2. Okay, since you know Q as minus 2, we can now substitute this value into any of the equation. Okay, and I'm going to pick equation 1. Okay, so you state substitute Q equal to minus 2 into equation 1. Okay, so what's equation 1? Equation 1 is 2p plus 5q equal to what? Minus what? 4. So let's put in minus 2 here. So we have 2p is plus 5 bracket minus 2 equal to what? Minus what? 4. So this is 2p plus that 5 times minus 2 will give us what? Minus 10 equal to what? Minus 4. So from here, take minus to this side. We have 2p is equal to minus 4 plus what? 10. And what is minus 4 plus 10? That will give us what? Is 6. So we have 2p is equal to 6. Divide both sides by 2. Okay, we have p is equal to 2 in 6 will go how many times? 3 times. So our scalars p and q is what? P is equal to 3 and q is equal to what? Minus 2. So this is our answer. Question 11b of our 2018 mathematics theory past question. It says, using a scale of 2 centimeters to 2 units on both axes, draw on a graph paper 2 perpendicular axes, okay, 0x and 0y, for these values respectively. Then it also says, draw on the graph paper indicating clearly the vertices and their coordinates. Okay, so we have here I. Okay, this is the first coordinates we have to draw. I, the quadrilateral W, X, Y, Z with this point. Okay, then I, the image of W1, X1, Y1, Z1 of the quadrilateral, this under an anti-clockwise rotation of 90 degrees about the origin where this. Okay, so how do we do this? Let's first of all draw this first quadrilateral, then we are going to solve this together. So it says using a scale of 2 centimeters to 2 units. Okay, so let's do this together. All right, so we have from here to here. Let's use this place. Okay, and you know, for the values of for x we have minus 5 to 5, and for the values of y we have what? Minus 5 to what? 5. So we can just you know, just draw it, just separate the graph sheet into 2 equal parts, so we can have 5 here and 5 here. All right, okay, I'm using a pen so you can see it clearly. All right, you're supposed to use a HB pencil. Okay, so we have this line here. Okay, we can draw another one here. Okay, all right, so this is our origin. Okay, this is our y-axis. This is our y-axis. This is our x-axis. Okay, so let's put in our values. So on the x-axis, it says from minus 5 to 5. Okay, so we are going to have a 1 here. And remember, it also says 2 centimeters to what? 2 units. So it means this first 2 centimeters would be what? 2. The second would be what? 4. Remember from my explanation on graph, then the third will be what? 8. So every 2 centimeters we have what? 2 units. So we can just stop here since we have, it says from minus 5 to what? 5. So 8 is okay because 5 will be in between here. And here we have a minus 2. We have here sorry, after 4 we have a 6 here, not 8. Okay, that's 2 plus what, 4. Okay, so we have minus 2 here, we have minus 4, and we have what, minus 6. Okay, so here we have 2. Okay, the question says using a scale of 2 centimeters to 2 units on both axes. So both axes, we're going to use what, 2 centimeters to what, 2 units. Okay, so we have 2 here, we have 4 here, and we have here 6. And here we have what, minus 2, we have here minus 4, and minus 6. Okay, so let us draw now the quadrilateral. Okay, the first point W says what? W has the point 2. This is X, this is Y. So we have X2 and Y at 3. So where is 3? Okay, how do we find 3? Remember when explaining how to get the values of each of these lines here. Okay, that's each of these points here. I said we have to do what? Since this is what, 2 centimeters to 2 units, and in 2 centimeters we have how many points do we have in 2 centimeters? We have 10 points, right? So all we need to do is just say what, 2 divided by what, 10. Since we are saying 2 centimeters to 2 units, 2 centimeters, what, we have 10 points, so we just say 2 divided by 10. And what is 2 divided by 10? So 2 divided by 10 is what, 0.2. So from here to here is what, 0.2. From here to here is 0.2, 0.2. So each of these values is what, 0.2. So if we have 2 here, we're trying to look for 3. Is that not it? We're trying to draw the coordinates of what, W, where the coordinates of W is what, X at 2, which you already have here, and Y at 3. So we have to look for 3 here. 3 would fall in between 2 and 4. And we know that each of these lines, this place is we've noted them as what, 0.2. Okay, so let us count. So if this is 2, so here will be what, 2.2. This point here will be what, 2.4. This point here will be 2.6. This point here will be 2.8. And definitely this point here will be what, 3, because 2.8 plus 0.2 will give us what, 3. So this point here is what, 3. Okay, this point here is 3. So we trace that out, and the point for W is what, this. Okay, and we'll make our star here. All right, so this is for W. We can just write W here. Okay, now the next point is what, X at what, 4 and what, minus what, 1. So this is the value for X, and this is the value for what, Y. Where is X at 4? This is X at 4. Then Y at what, minus 1. So how do we get minus 1 from here? Remember, each of our values is what, 0.2. Okay, so this will be what, 0.2. Okay, that's minus 0.2 plus minus 0.2. You know, this is the negative side of Y. All right, this is the negative side of Y. So we have 0.2 here, 0.2 plus another 0.2. We have 0.4, we have 0.6, we have 0.8, and definitely we have what, 1 here. Okay, so this is the point value for what, 1. So we trace this out to what, 4. It is what, 4 and what, X, this X is at what, 4. The coordinates of this X is at what, 4 and what, minus 1. Okay, so we have 4 here and minus 1 here. So this is our point here, and we'll put the star here. Okay, what's the next thing? Y is at the coordinates of what, X at minus 3 and Y at what, minus 4. Okay, so where is X at minus 3? Okay, let's try to find X at minus 3. This is our X-axis. So if this is 2, we have a 2.2 here, 2.4. You know, we're using the same scale on both axes. That's 2 centimeters to 2 units. If it was a different one, you know, we also have to formulate a way to get each of our points here. But since it's the same scale on both axes, it is still 0.2. Okay, so here we are looking for what, where X is what, minus 3. Is that not it? So here is what, 2.2, 2.4, 2.6, 2.8. Then we have our 3 here. So 3 is here. Okay, and minus 4. Where's minus 4 on Y? Okay, this is it. This is it here. All right, so we trace down this. So this is Y at minus 4 and X at what, minus what, 3. So this is another point here. Okay, remember we're drawing a quadrilateral, all right? That's what the question says. So our final coordinates, which is what z for the quadrilateral, is what z at what? Is at what? X at -3 and y at 2. Okay, so where is x at -3? Okay, this is still x at -3 and y at 2. Okay, this is y at +2. So we have our point here, y at 2 and x at -3. So our point is what's here. All right. Okay, so we have, this is what, this point here is what? X. So let's just label it as x here. This point here is what? Y. So we just write y here. And this point here is what? Z. And you put Z. Okay? In your notebook, you're using a pencil, so you also put Z. All right? So let's draw the quadrilateral now. So let's draw our point. Let's draw the quadrilateral. So we have this from here. Okay. A quadrilateral has 4 sides. Okay. Then we have this. And finally, we have this point here. Don't make a mistake and draw your point to here, okay? I actually made that mistake too. All right? So make sure you label out your X boldly so it doesn't look like a point, okay? All right, so we have this quadrilateral here. So this is the answer to I, okay? That's the answer to this, all right? Now, the next question, that's the final one, says the image of this WI, XI, YI, and ZI of the quadrilateral this under an anti-clockwise rotation of 90 degrees about the origin are where this. So we have to draw the image, okay? When this image has been turned what? Anti-clockwise at a rotation of what? 90 degree. Okay, so it means that each of these points now, each of these coordinates, their coordinates will what? Will change. So we have to find the new coordinates. So how do we do this? Okay, let's do this together. So we know that normally this is how this Cartesian what coordinate is. Okay, this is the normal one, y at x. So if it is turned anti-clockwise now, a rotation of 90 degrees, that means it will move this way. Okay, is that not it? It's going to move. So x will come up. So it means x now will become y. All right, so x will come up now and it will become what? Y. And y would go down. Okay, so y will go down and become what? Minus what? Y. So y will be equal to what? Minus y. Are you saying this? Okay, so when you rotate it what? Anti-clockwise, that's, you know, anti-clockwise, the clock rotation is this way, clock rotation is this way, but anti-clockwise is what? This other way. And we moved what? 90 what degree. So it means x would come up, y will go down. So as x comes up, x becomes y, and y now becomes what? Minus y, because when you take it to this side, remember in our graph sheet, on this side it will become what? A negative. Okay, so y will become what? Minus what? Y. All right, so we have to now find the new coordinates of what? This w. So we have here the first coordinate of this w is what? 2, 3. Okay, so our new coordinate, which is what? W prime, will be what? As I said, this is x and this is y. So x becomes what? Y. Is that not it? X becomes y. So it means that for our coordinate for y here, x becomes what? Y. So this will be what? 2. Y becomes what? Minus what? Y. So we are going to have what? Minus 3. Are you following me? Let us do another one together again. So here again we have our old coordinates is what? X bracket what? 4, minus what? 1. So this is x and this is y. Our new coordinates for x now, after the anti-clockwise rotation of 90 degree, will be what? Our y will become what? X. Since I said when we rotate, x becomes what? Y. Okay, so y will be what? 4. Y, your new value for y will be what? Minus y. So it means we will have what? Minus times minus what? 1. And what is minus times minus 1? We are going to get what? A 1. Our next value, y, which our old value is minus 3 comma minus 4. Here you have, this is x, this is y. So y prime will be what? X will become y. So we have minus 3, and y will become what? Minus 4, which is minus times minus 4, which will give us what? 4. So these are new values for what? Y prime. Then for our final value, which is z, our old value for z is what? Minus 3 comma 2. Our new value for z prime will be what? This is x and this is y. X becomes what? Y. So this value for x becomes what? Minus what? For new z, it's what? Minus 3. Y becomes what? Minus what? Y, which will be minus times this what? 2. And we have what? Minus 2. So these are the new coordinates of what? A new quadrilateral after the anticlockwise rotation, okay, of 90 degrees of this one, okay? So now we're going to get our point now. I'm going to use a black pen now. Okay, so our point for the new quadrilateral after an anticlockwise rotation of 90 degrees, we have here x and y. So w is what? X at what? Minus 3. Where's x at minus 3? Okay, this is x at minus 3 and y at 2. So you can see here w becomes z. Okay, so we have a point here, w. Okay, I'm going to use the black pen so we can differentiate our quadrilateral. Okay, the next one, xi. Okay, x1 becomes what? 1. X is 1 and y is what? 4. Okay, so where is x at 1? Okay, x at 1 will be somewhere here, all right? And y is what? Is what? 4. We have a positive 4. Is that not it? So where is x? Where is y at 4? Y at 4 is somewhere here. Okay, so we are going to have our x point now becomes here. All right, I hope this is 1. Okay, let us check if this is 1. So we have here, this should be 0 0.2, 0 0.4, 0 0.6, 0 0.8, then 0 0.8 plus another 0 0.2 will give us 1. So this is 1. Okay, so we trace that up down to 4. Okay, so this is our coordinate for what? Our new what? X1. Okay, so this should be W1, sorry, here, and this should be what? X1. Okay, all right, so for y1 we have what? X at 4 and y at what? Minus what? 3. Okay, so where is x at 4? X at 4 is here, and y at minus 3. Where is minus 3? Minus 3 will be somewhere here. This is y-axis. Minus 3 should be somewhere here. Okay, this is 2. This is 2.2, 2.4, 2.6, 2.8 and 2.8 plus another 0.2 will give us what? 3. So 3 is here. Okay, so minus 3, then we trace it down to x at what? 4. Okay, and this is x at 4. So our point is what? Here. Okay, and we have here y what? 1. Okay, so our final point is what? Z prime or Z1. Okay, so Z1 has what? X at what? Minus 2 and y at minus 3. So where is x at minus 2? Okay, so this is our x-axis. X at minus 2 is over here. And where is y at minus 3? This is our y-axis. Y at minus 3 is here. Okay, so we have our point here, x at minus 2 and y at what? Minus 3. So we have this point here. Okay, so this is our point for what? Let's label it. Should we come down here? Okay, this point will be what? Or let's put it close by here. Z what? 1. So let us draw our quadrilateral out now. Okay, so we have this point and this point for W, this point for X. Okay, we have this point again here. That's for our second quadrilateral after an anticlockwise rotation of what? 90 degree. Okay, and we have another point here. Sorry. Okay, then our final point. Okay, so this is the final word quadrilateral. Sorry for this mistake over here. All right, so this is the final answer. So this is the image of the second word quadrilateral after an anti-clockwise rotation of what 90 degrees. So do we notice anything at all with these two images here? You can see the shift of what that anti-clockwise rotation. You can see W. Do you see this invert? You see the way W came towards here and Z and Y became here, and what's the next one? Then Y and X came here. Okay, you can see that anti-clockwise what rotation. You can just see that here. W, this is our first image, is that not it? W and X, you can see W came here while X went there in the second image. So this is the answer for question 12B. Question 13A of the WAS 2018 Mathematics Theory question. It says the frequency table shows the marks distribution of a class of 30 students in an examination. The mean mark of the distribution is what? 52. So we've been told our mean is what? As our x bar is equal to what? 52. And we've been told that the frequency table, the marks distribution of the class of 30 students. So we've been told the total frequency as what? 30. Okay, so total frequency is what? 30, which is what? Summation of what? F is equal to what? 30. Okay, the question says find the values of x and y. Okay, to find the values of x and y, we have to have two equations so that we can equate them or use simultaneous equation to get one value, then get the other value. All right, so we have to have two equations here. But first of all, let's try to find the mean. Okay, let's try to calculate the mean with x and y. Okay, all right, so let's draw our table. So we have here marks, then our f, which is our frequency, then we have our fx. Remember that your mean, the formula for mean, you are going to state the formula for mean is equal to what? The summation of what? Fx over the summation of what? F. Okay, let me state it here. Okay, write the formula for mean as what? The summation of what? Fx over the summation of what? F. Okay, and our marks are what? 10. We have 20, we have 30. It's always good you separate it, okay, so you don't mix up the numbers. We have 40, we have 50, we have 60, we have 70, we have 80, and we have what? 90. Okay, so the frequency of 10 here from our table is what? 1. Frequency of 20 is 1. The frequency of 30 is x. The frequency of 40 is 5. For 50 we have y. For 60 we have 1. For 70 we have 4. For 80 we have 3. And for 90 we have what? 1. So we are going to get what? Fx. This is what? X. This x is your mark. So you multiply this. So 10 times 1 we have what? 10. And 20 times 1 we have 20. 30 times x we have what? 30x. 40 times 5 we have what? 200. 50 times y we have 50y. And 60 times 1 we have 60. 70 times 4 we have what? 280. And 80 times 3 we have 240. And 90 times 1 we have what? 90. So what's the summation of f? Okay, since our mean is what? The summation of fx over summation of f. For here the summation of, let's find the summation of f first. We have 1 plus 1, which is 2. 2 plus 5, that is 7. Plus 1, that is 8. Plus 4 we have a 12. And 12 plus 3 we have 15. And 15 plus 1 we have 16. And remember our x and y. So summation of f is equal to what? X plus y plus what? 16. Okay, that's when you add the total digits. We have 16. Then remember x plus y. All right, so let's find the total summation of what? Fx. So total summation of fx will be equal to That's, we have our 30y and 50y. So you are going to write your 30x, I mean 30x plus what, 50y. When you add up all these digits, we're going to get what, 900, okay, plus 900. All right, so this is summation of fx and what, f. So you're going to state here our mean is what, 30x plus 50y plus 900 divided by what, x plus y plus 16. And don't forget, we've been given our mean as what, 52. Is that not it? From the question, say the mean mark of the distribution is what, 52. So it's equal to what, 52. Okay, so let's try to simplify this so we have one equation. All right, from here we've been given our mean as what, 52. Okay, so let's try to simplify this so we have one equation. So all we need to do is what, cross multiply. Is that not it? Take this here, so we are left with here 30x plus 50y plus 900 equal to 52 bracket x plus y plus 16. Okay, so we have here 30x plus 50y plus 900. If opening the bracket, we have 52x plus what, 52y plus what is 52 plus 16, it's sorry 52 times 16, we are going to get what, 832. Okay, so from here let us simplify. Let's take all the values of x and y to this side, bring the digits to this side. So here we have 30x, bringing 52 here, 52x, we have what, minus what, 52x, then plus 50y, bringing plus 52y here, we have what, minus what, 52y, equal to 832. Taking plus 900 here, it's going to be a negative what, 900. So from here, what do we have? 30x minus 52y will give us a minus what, 22x, and 50y minus 52y will give us a minus what, 2y, equal to this minus this will also give us what, a negative what, 68. From here we can simplify this, we can cancel out the negative sign, and we can also divide by 2 to make our equation simple. Okay, so we just say we divide both sides by what, minus 2. So divide here by minus 2, divide here by minus 2, divide here by minus 2. So 2 in 22 will give us what, 11, and this negative will cancel out this 11, so we have 11x, and minus 2 in minus 2 will definitely give us a plus 1, and 1 times y is what, a y, so we have what, plus what, y. This negative will cancel out this negative, and 2 will cancel out as 1, and 1 times y is what, y. And this will be equal to, this negative will cancel out this negative, 2 in 684, 2 in 68 will give us what, 34. Okay, so we have this equation here, so this is equation 1. All right, now remember that we're given the value of what, our summation of f. We're given the value of our summation of f as what, 30. So this is what, equal to what, 30. So this is our equation 2. Okay, so we can now use these two equations now to get our values of x and y. So from here, if we simplify this, okay, I'm trying to manage the space here, that's why I'm not solving it like in full, but you make sure you solve it in full. From here, if we simplify this, we're going to get here x plus y. Taking 16 to this side, we have what, 30 minus 16. And what is 30 minus 16? That will give us a 14. So we have here x plus y equal to what, 14. So this is our equation what, 2. Okay, so from here it is easy for us to cancel out, okay, using elimination method. All right, since we have y here, all we need to do is introduce a negative sign. So when we introduce a negative sign, we have this. So this negative sign will affect x, and this it will affect this positive sign. This will be a negative, and this 14 here will carry a negative. So we can cancel out this one. So we have here 11x minus x. That will give us what, 10x, equal to what is 4. So what is 34 minus 14? 34 minus 14 will give us what, a 20. So from here we can simply get, okay, so from here we can simply get, this is what, 10x is equal to what, 20. So divide both sides by what, 10. and x is equal to what? 2. 10 in 20 is what? 2. So as we've gotten the value of x as 2, we can substitute this value into equation what? 2, where equation 2 is what? X plus y equal to 14. Okay, make sure you state that. You say substituting the value of x as 2 into equation what? 2. Okay, so from here we have 2 plus what? Y equal to what? 14. All right, so take 2 to this side. We have y is equal to 14 minus 2, and what would that give us? 14 minus 2 will give us a 12. So therefore our values of x and y, x is equal to 2 and y is equal to what? 12. So this is our answer to question 13a. Okay, so we're going to use this answer to complete our table for question 13b. Question 13b of the WASS 2018 Mathematics Theory Past question. It says, construct a group of frequency distribution table starting with the lower class limit of 1 and a class interval of 10. Okay, we've solved the 13a, okay, where we were told to look for x and y. This was the table we were given in 13a and told to look for x and y, and the solution from our 13a, that's, you should have watched that video before this one, okay, is what? The solution for x is what? 2, and the solution for y is what? 12. So this will be equal to 2 and this will be equal to what? 12. So question 13b now says construct a group frequency distribution table. So we have to construct the table, and when you're constructing a table for your group frequency distribution, the 3 key things you're going to have is your class interval or class max. Okay, here it is class max. Okay, class interval or max. Okay, all right, this is the first thing you need. Okay, I'm going to draw a line here because it's a table. Okay, then the next thing is your class boundary. Okay, that's your class boundaries. Let's draw another line. Then finally your frequency, which you've been given here. Okay, okay, so just draw a table. All right, so you can actually call it the class max or class interval. Okay, that's for this. All right, okay, so what's our class interval? They said, the question said, and a class interval of 10. So we have from 1 to 10. What's the highest mark here? It was 9, is what? 90. So we are going to have from 1 to 10, then to 90. So from 1 to 10, we have 11 to what? 20. Then we have 21 to what? 30. And we have 31 to 40, and we have 41 to what? 50, and we have 51 to 60, and we have 61 to 70, and we have 71 to 80, and we have 81 to what? 90. Okay, so we're going to stop at 90. So these are class what? Max. It stops at what? The highest is what? Mark what is what? 90. So this, we're going to stop here. Okay, so our class boundary now. Okay, our class boundary, since this is a 1 here, not a 0, so it won't start from a 0. It will start from what? A 0.5 to what? A 10.5. Now, how do you find your class boundary? That's this part. It's just, you just say the upper limit of this particular first class interval plus what? The lower limit of the second class interval, then divide by 100. It's just saying 10 plus 11 divided by 2, and that, which is 21 divided by what? 2, and which you are going to get what? 10.5. That's how we got 10.5. So you're going to start here also with what? 10.5, and to get this next part is definitely this plus this divided by what? 2. That's 20 plus 21 divided by 2, which is what? 41 divided by 2, which will give us what? 20.5. So you have what? 20.5 here. We're going to start here with 20.5, and definitely this will be just add points, just 0.5 to the 30, okay? Because if you calculate it continuously, that's what we're going to always have. We have an addition of 0.5 to all this, all right? Okay, so we have here 30.5, or do you want me to do this again? Let me do this again for you. Here we have 30 plus 31 over 2. This will be what? 61 divided by 2 will give us what? 30.5. So you see what I mean? Okay, so we have 30.5 here. Then we have, let's just add 0.5 to all this, okay? So we have 40.5. We have 40.5 here. And we're going to have what? 50.5. Okay, are you following me? Are you with me? Here we have what? 50.5 here. And we're going to have here 60.5. Here we are going to bring 60.5 here, and I'm going to have 70.5 here. Here we're going to have 70.5, and we're going to have 80.5 here. Here we're going to have 80.5, and finally we're going to have what? 90.5. Okay, so these are our class boundaries for this class marks. Okay, and our frequency from here, for the mark from 1 to 10, we have a frequency of what? 1. For 20, we have what? 1. We've calculated this x as 2, so for the class interval of 30, our frequency is what? 2. For 40 here we have what? 5. For 50 we have what? 12. For 60 we have 1. For 70 we have 4. For 80 we have 3, and finally for 90 our frequency is what? 1. Okay, so this is the answer to what? Question 113b. Construct a group frequency distribution table starting with a lower class limit of what? 1. Okay, and a class interval of 10. Okay, that's why you have 1 to 10. Okay, sometimes they might tell you to start with what? 0. So this will start with what? 0. Okay, but for us the question says what? Start with 1. Then our 13c says draw a histogram for the distribution. Okay, so we're going to draw our histogram now. All right, okay, so in drawing we have to pick a scale. All right, now for our y-axis, what scale should we pick? For our y-axis, to draw a histogram, you draw your frequency versus your class boundary. Okay, so your frequency is going to be on your y-axis, while the class boundaries will be on the x-axis. Okay, so we're using our class boundaries to plot against our frequencies. Okay, so our frequency will be on our y-axis, while our class boundary will be on the x-axis. So I'm going to set a scale. You must always mention the scale you're going to use on your graph. Okay, so for my x-axis, that's on my class boundary. Okay, I'm going to use what? You're going to write it on your graph sheet. I'm going to use 2 centimeter to 10 units. Okay, since we have a difference of 10, 10, 10 here. All right, okay, you know, this minus this is 10, this minus this, so I'm going to use 2 centimeter to 10 units. Then on my frequency, that's our y-axis, I'm going to use 2 centimeter to 2 units. Okay, so because the highest frequency here is what? 12. All right, so let's plot our graph now with our scale. Please make sure you state your scale down. All right, okay, let me have a straight line here. Okay, I think we can stop here. Okay, and here. So let's have this. It's our x-axis, and this is our y-axis. I hope you can see that. Okay, so on our x-axis we have 2 centimeter to what? 2 units. That's on our y-axis, I mean. So we have here 2, we have 4, we have 6, we have 8, we have 10, then we have what? 12. Okay, that's 2 centimeter to what? 2 units. And here we have what? 10 centimeter to what? 10 centimeters to what? 10 units. So from here to here we are going to have what? 10.5 using our upper class boundary. From here to here we have 20.5. Okay, this minus this is 10. Okay, and here to here we have 30.5. We have here 40.5. We have here 50.5. we have here 60.5, we have here 70.5, we have here 80.5, and finally we have 90.5. Okay, all right, and we're just going to assume somewhere around here is 0.05, okay, because our class boundary starts from 0.5 to 10, but you know histogram is always an estimate. Okay, so let's just leave it this way. Okay, so for our first frequency for our upper class boundary 10.5, we have a frequency of 1. So where will 1 fall? 1 will fall around here. Okay, remember how I told you to get the value of each of these lines? You just simply, since this is 2 centimeters to 2 units on our y-axis, you just simply say 2 divided by 10, which is about 0.2. So each of these spaces is 0.2. So to find where 1 will fall, we have 0.2, 0.4, plus another 0.2, that's 0.6, plus another, that's 0.8, then 1. 1 is here. Okay, so we have our first value here. So we're going to draw a line. No histogram, you have no spaces. Okay, but a bar chart, you have spaces in between them. All right, but Histogram, there are no spaces between the class boundaries. All right, so for our next upper class boundary 20, the frequency is what? 1. Is that not it? I hope you're following me. So for 20, our frequency is what? 1. Let's draw a line here, down here. Draw this down here. Okay, the next one, our frequency is what? 2. That's for 30. So 30 is 2. So from here to here. Okay, we have here. Let's just leave this line. We will still trace it down. Then the next one is what? 5. Okay, for 40, we have here, where will 5 fall? 5 will fall somewhere here. Okay, this is 4, 4.2, 4.4, 4.6, 4.8, and 4.5. Okay, so we draw here. This is our class boundary. That's from 30.5 towards 40.5. Okay, and we draw this. Okay, so let's get our class boundary for what? 40.5 to 50.5, and this is what? 12. That's the highest. Okay, this is the highest frequency here. So right here, so this is from 40.5 towards 50.5. All right, and we draw down here. Remember, you're not to use a pen, an ink pen. You have to use a pencil to draw yours, HB pencil. Okay, all right, our next one, class boundary from 50.5 to 60.5. That's from 50.5 to 60.5. We have 1. So it comes down back again to what? 1. And where does 1 falls here? Okay, so let's draw a line down here. Okay, all right, our next class boundary, the frequency is what? 4. That is from 60.5 towards 70.5. 60.5 to 70.5, and 4 is right here. That's the frequency. Okay, we can just draw this now, or let's just hold on. Okay, and our next class boundary is what? 70.5 to 80.5, which is what? 3. The frequency is 3. And where would 3 fall? 3 will fall somewhere here. Let's count. I think to fall here, that's 2.2, 2.2, 2.4, 2.6, 2.8, then 3. Okay, and we'll draw this here. All right, then the next one is what? 80.5 to 90, which is what? 1. So definitely we are going to have 1 here. All right, let's just draw. Okay, so let's finish this now. Okay, and finally this. So this is the answer to question 113 what C, which says draw a histogram for the what? Distribution. So this is your answer. This is another mark. Now the next thing we have to find is question 13 what D. Use the histogram to what estimate the mode. Okay, we always use histogram to find the estimated what mode. So how do you do this? Now you're going to check in your histogram the graph. Okay, where is the highest bar with the highest frequency? This is it. Okay, so all you need to do is draw a line from the two class boundaries. Now from your lower class boundary, draw a line to meet on the side, the side of the next class boundary. Okay, from your lower class boundary, draw a line to meet the next lower class boundary, okay, of the next class interval. Okay, so draw a line to meet it at this point. All right, I'm going to draw this line. Okay, then from the upper class boundary of the bar with the highest frequency, draw a line to meet the upper class boundary of the one before this particular class boundary. Okay, that's from here to here. I hope you're following me. It's like just drawing a cross. Okay, but now the cross must touch this point and this point. Okay, then when you have this, you trace the point to the x-axis to get your estimated what mode. Okay, so let's trace this point. Okay, this point is going to fall here. Oh, sorry, I'm not supposed to draw a line. Okay, I'm supposed to like trace it. Okay, we're supposed to trace it out. Sorry, I drew a line there. Okay, so just trace it out. Okay, not a line, just trace it out down here. All right, okay. And what is this value here? We have to find it. So here we have 40 what? This is 40.5. Okay, so definitely this will be 41, this will be 42, this is 43, and this is what? 44. So definitely our estimated mode is what? 44. Okay, so the answer for our estimated mode is what? 44. So you're going to draw this, then trace a line, not just trace out a line to get your value on the x-axis. So our estimated mode is what? 44. So our answer is what? 44. So we've come to the end of the WAEC 2018 mathematics theory question. I hope you